Hello guys, welcome back to STEM Trainers. Now in the previous videos we have seen in moments that when a body is in equilibrium what happens, how to do the analysis, how to find the moment. And then in the second video we have seen if a uniform rod or uniform beam is given, how to do the analysis for center of mass. And if non-uniform rod or beam is there, then how to do the analysis and find where the center of mass is, etc. etc. So now this is our third video in moment section. Now in this video we will talk about tilting. So I know that most of the students have problem in tilting. So in this chapter the most uh, difficult thing that students find is tilting. So let's discuss this. What is tilting? So when a rigid body is on the point of tilting about a pivot, the reaction at any other support is zero. So whenever we say a body is on the point of tilting about a point, then the reaction at other points or other supports will be zero. So we will see this with the help of some examples. So let's try to understand this. So this is our first question. A uniform beam of mass 45 kg and length 16 meter rests horizontally on support C and D as shown. So we have a uniform beam. AB mass is given 45, and as it is given as uniform, so obviously we have done this in previous video. So center of mass will be exactly at center. So what's the length of this is 16. This is 5. This is so somewhere here there will be center of mass, and we know this will be this mass is nothing but 45 kg. So this is 45 g. Okay. So when a child stands at A, so there is a child standing at A. Okay, so the mass of the child we have to find so that the beam is on the point of tilting about C. Okay, so mass we don't know, so let's take that as M. So this force is mg. So now there will be reaction force at C, right? And there is reaction force at D. Now, when the beam is on the point of tilting about C. Now you can vision this, right? What happens is when the beam is about to tilt at point C, so this beam will try to move upwards like this. And when it will try to move upwards like this, what happens is you can see that reaction force at D will be zero because there will be no contact between the rod and this support D. And that is what is there in definition also. So when it is about to tilt about a pivot, the reaction at other supports is zero. So what we will do is, we know that reaction at D will be zero. Now this is our diagram, correct? So we discussed that whenever we are solving mechanics question, we will make a diagram, rough diagram, and then we will draw all the forces. Okay, and we know this is zero. So I am not drawing reaction at D. Okay, so we have to find the mass of the child, and we know that moment about C will be equal to 0. Moment about C will be equal to 0. And reaction force at D will be 0. Okay, so when we take moment at C, so for mg, so mg, this is the force, it will go this direction. What is this direction? This is nothing but anti-clockwise. So mg times the distance is 5. And what about the moment for force 45g, that is the weight? So weight is like this, and we are taking moment about C, so it will try to go like this, and this direction is nothing but clockwise. So anti-clockwise moment should be equal to clockwise moment. So that is 45g times this distance is how much? This is 16, so this is 3 meters, right? Center of mass. So into 3. So we can cancel this g. So m is coming out to be 45 times 3 divided by 5. So which is nothing but 27 kgs. So that is our answer. So I hope you understand this. The only new thing that we are introducing is whenever the beam is about to tilt, the reaction at other supports is 0. Okay, let's try another problem and see. Okay, so now a non-uniform rod AB of length 10 meters and weight 40 newtons is suspended from a pair of cables as shown. Okay, at C and D. Okay, so at C and D there are two cables. When a weight of 25 Newton is hung from A, so there is a weight of 25 Newtons. Now be careful, this is not 25 kg, this is 25 Newtons. And the weight of the rod is 40 Newtons and it is non-uniform. So we don't know where center of mass is. Okay, the rod is on the point of rotating. Okay, so now the rod is on the point of rotating. Now mass is hung from A, so obviously it will try to go like this, right? Upwards like this. So it means the reaction, or you can say the tension at D will be 0. So there will be some tension at C point, but tension at D point will be 0 when it is on the point of rotating. So find the distance of center of mass of the rod from A. So we don't know where center of mass is. So let's assume it's somewhere here. You can assume anywhere. This is 40 Newtons. We need to find its distance from A. So this distance, let's assume this distance as X. So we need to find this value X. So again, we will do the same thing. We will take moments about C, and net moment about C will be 0, or you can say clockwise moment will be equal to anti-clockwise moment. So let's take this 25 Newton moment, and this 25 Newton moment will be, this will be like this, right? About C we are taking. So obviously this is which direction? Anti-clockwise. So anti-clockwise moment is 25 times 3. And what about this 40 Newton? So 40 Newton will be like this, and this direction is nothing but clockwise direction. So anti-clockwise moment will be equal to clockwise moment. Clockwise moment is 40 into this distance. So we don't know this distance. Let's assume this point as E. So what we will do is, this total is X. So this small thing is X minus 3. Right? Because AE is X and AC is 3. So CE will be X minus 3. So into X minus 3. So what we are doing is clockwise moment is equal to anti-clockwise moment. So what we are getting is 75 equals 40x minus 120. So 195 is equal to 40x. So my x is coming out to be 195 divided by 40, which is nothing but 4.875 meters. So that is our answer. So center of mass is at a distance of 4.875 meters from A. Now remember, we discussed this in previous videos also. Why I am taking moment about C? So that there is no moment of tension C. So if you take moment about any other point, then what will happen is you will have to find the value of tension. And same in last question also. We took moments about C, because in that case then moment of RC, that is reaction force at C, will be 0. So you don't have to calculate the value of R, reaction at C. Okay, I hope you understand this. Okay, let's try this last question. This is a very important question, and this is exam style question. Let's understand this. A uniform beam AB of weight W and length 14 meters hangs in equilibrium in a horizontal position from two vertical cables attached at points C and D, where AC is given, BD is given. Okay, so AC is given, BD is given, and CD we will calculate because total length is 14. Okay, so we know all the lengths. A weight of 180 Newton is hung from A. So weight of 180 Newtons is hung from A. Okay, so some weight 180 Newtons is hung from A, and the beam is about to tilt. Now obviously when you put some weight on A and the beam is about to tilt, so obviously the beam will try to go in this direction like this, and when it will try to go in this direction, then what happens is the tension at D will be 0. Right? We have studied this. Now it is on the point of tilting. Okay, so then they are saying the weight is removed. Okay, 180 weight is removed and a different weight is hung from B, and the beam does not tilt. Find the maximum value of B. Okay, so let's try to solve this. This is a very big question. So let's analyze this slowly. So now for the first part, when a weight of 180 is hung, initially it was in equilibrium. So this is, let's say, some tension C. Okay. Now initially it was in equilibrium. When weight is hung, it is about to tilt. So we have taken that reaction at D will be 0. Now we don't know the weight, but it's a uniform beam. When it's a uniform beam, so we can say that its center of mass will be exactly at center. So 4, 8, 14, 7. So exactly here, this will be its weight. And weight is also not given. Let's take that as W. And this distance is 3 meters. Because 14 by 2 is 7. So this total should be 7 from A to W. Okay. Now, again, let's take moment about C. Why is because so that we don't have to find the tension. So moment about C will be 0, or we can say clockwise moment is equal to anti-clockwise moment. Now this moment will be nothing but anti-clockwise. So what's the value of this? So this is nothing but 180 times 4. And this should be equal to the clockwise moment of W. So this will be the moment clockwise. What is this value? W times 3. So from this we can calculate W. So this is 60 into 4, that is 240. So this is 240. So this is my weight of the beam AB. Okay. So now the second part they have given is the weight is removed and a different weight Vn is hung from B. So now this time what they have done is they have removed this weight and a new weight V is hung from B point. And the beam does not tilt. Find the maximum value of V. So that's the question now. So now what will happen is, now try to analyze this. This is my reaction force like this. Okay. In order to find the maximum value of V, we can say that V will be maximum when the beam is about to tilt, right? When the beam is about to tilt. So now the weight is hung from V point. So when it will tilt, it will try to go in this direction, the beam. And when it will try to go in this direction, what will happen is tension at C will be 0. So this is my second case. Now in second case, tension at C will be 0. Now this is important. So again, what we will do is we can say that moment about D will be 0. Or you can say that clockwise moments will be equal to anti-clockwise moments. So at D point, what are my moments? So this weight W will be there, and this is how much? This is 1 meter, right? This total was 8 from A to D. Center of mass is at a distance of 7 from A, so this is 1 meter. So moment for W, so this will be in this direction, that is anti-clockwise direction. W into 1 should be equal to the new weight V, which is the maximum weight we are taking, so that it is tilting. So V into how much distance is this? This is 6, right? So this is 6, and this direction is, always see the direction. This is clockwise direction, and W moment is anti-clockwise. So clockwise moment should be equal to anti-clockwise moment. And in the previous part, we have already found the W value. So 240 into 1 divided by 6 will be our V. And V is coming out to be 40 newtons. So what's my answer here? The maximum weight V can be 40 newtons. So if it is greater than 40, then what will happen is the beam will tilt, and we don't want beam to be tilted, and it says beam does not tilt. So if it's anything less than 40, then beam will not tilt, and that's the question. So maximum value is 40. I hope you understand this. So this is an exam style question, and this is very important. So in most of the question you will see that they will ask you this two part question. So first they will give you some weights or some conditions. From that you will find either the weight or center of mass or some tension or some other weight, and then they will ask you another part. So like in this question 3. So I hope you understand this. If there is any doubt, you can email me or you can write it in the comments. And please, if this is helping you in any way, please like and subscribe and share as much as possible. Thanks for watching STEM Trainers.